Hello everyone. In this section, we will discuss one of the key elements of lean production, just in time, and go through the concept of push-pull. Our learning objectives are to describe the principle of just-in-time, or JIT, understand the concept of pull systems as they apply to JIT, and we want to start by going through production planning so that you can list the basic elements of classical production planning, the customer demand forecast, the aggregate plan, the master production schedule, and material requirements planning. And finally, we want to discuss the significance of just-in-time for lean production. We defined the 3 M's of lean: Mura, Muri, and Muda. We first understood how to calculate resource capacities, and then with setup time reduction and optimal batching decisions, and with demand management and smoothing, we worked towards establishing a continuous production flow. We also saw how reducing variability and keeping our resource utilization low keeps us from overburdening our resources. This preparation leads to a reduction of waste, in particular reducing wasted time and inventory. And as we said before, inventory plays a particularly critical role. Inventory increases our flow time, according to Little's Law, and inventory has a cost as it ties up working capital, increases operational costs, including things like conveyance and storage, and there's a risk of inventory obsolescence. Also, we learned that excess inventory is often a symptom of problems in a process that are hidden behind the rising stock levels. Inventory masks inefficiencies in the production processes, also waste, and in the supply chain design. It allows us to meet the customer requirements despite poor process performance because of our buffer inventory. Toyota recognized this waste and the importance of quantity control. Just-in-time production then became a key pillar of the Toyota production system. Just-in-time means to produce only what is needed, when it is needed, and in the quantity needed, and importantly, to enforce this throughout the production, and indeed the supply chain. The ideal state is that a workstation receives material from an upstream process exactly when those materials are needed and in the quantity required. To achieve JIT, Toyota and other companies have spent substantial efforts to create the requirements in their production system design rather than taking this for granted. Because JIT requires a very stable production system. We need to create continuous flow, reduce Mura, reduce burden, Muri, and then JIT can be realized, which in itself reduces waste, Muda. We will look at techniques to realize just-in-time, but we need to go back a step and first review the concept of a push and pull system. And then we want to look at how production planning is done. The push-pull view is used very often, particularly to discuss supply chain management. The basic idea is that a process that is done before the actual demand, based on forecasts, is known as a push process, whereas pull processes are in response to actual demand. Now, for example, and here we're going to move over to Asia. In Singapore, you have the famous hawker centers, or the food courts, and there are many stalls where you stand in line and then you request the dish that you want, and then the food is prepared as you wait. The customer orders, and then the production begins. As opposed to, for example, many other examples, but in a grocery store, the food is stocked and customers come in and purchase the inventory which is already waiting for them. So the hawker center, you have a pull process. Grocery store, you have a push process. Now, the push-pull view is discussed often with respect to forecast accuracy, or rather the lack thereof. The further in advance we make a forecast, the less accurate it is. And additionally, another important point in supply chain management is that an aggregate forecast is more accurate than a disaggregate forecast. That is, the individual forecasts, for example, if a camera comes in many different color cases, the individual forecasts for those particular colors of the specific camera type are less accurate than the aggregate forecast for that camera type in all colors. And this brings us again to the powerful idea of postponement. or delaying the differentiation till as late as possible in production when you're close to actually selling those cameras, close to the customer demand. And then you would start to differentiate your different color cases. There's always an element of push and pull in any production supply chain. For our Hawker Center example, normally the rice is cooked ahead of time and ready to be served, and the vegetables and meat are already available, they just need to be cooked. For example, customer furniture design, you don't wait for the trees to grow before you build your table. So all systems have both push and pull elements, or at least someone in the system has to push. But the power of a perfect pull system is that you follow the demand to produce as close as possible to what is needed. You have to order the amount of material when it is needed to have those resources available just in time. Now, the downside is that the customers don't want to wait around for their parts. So in actual fact, a true pull process, a make-to-order process, is really a special case. For this course, we want to adapt our simple push-pull definition and use the definition from Hoppe, Spearman, and factory physics. And that is that the real difference between a push and pull system is that in push systems, there's no limit imposed on the downstream work in progress inventory, whereas pull systems there is. And here the idea is that in a pull system, the production should follow the average demand given by our TACT, the available time in a period over the demand in a period. Then, with enough capacity in our system, our flow rate is equal to the rate of demand. And here we already see that using TACT already smooths our demand to a demand over a period. And obviously the work in progress must be ready to meet that demand. So according to the TACT, resources must be available and parts must be ordered. So how can we establish a pull system and have everything in our system ready for just-in-time production? First, let's take a look at classical production planning.